Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In today's video, we're going to be talking about molarity. And what molarity is, it talks about how concentrated a solution is. Now, you may be familiar with the vocabulary words dilute or concentrated. Dilute being when a solution has lots of water in it. Concentrated meaning that there's not a lot of water in it. And that tells you the kind of like the concentration, but that's telling you the concentration from a qualitative perspective, okay? What molarity does for us is it puts a number to it according to this equation right here, so we know exactly how concentrated or how dilute the solution is, okay? Now, just a quick review. We know that solutions are going to have two parts. It's going to have the solute part, okay? And that's the part that you're dissolving, okay? And it has a solvent part. And the solvent part is what's doing the dissolving. Most times, this is usually a solid, but it doesn't have to be. And the solvent in an introductory chemistry class is usually water, but it doesn't have to be either, okay? These are just kind of like the generalizations. So usually a solid, usually water to make our solutions, okay? And if we make our solutions, okay, we are going to have a certain level of concentration for the solution, and it's calculated using this thing called the molarity equation. So molarity is just a fancy word to talk about concentration because there's a lot of different methods that we can use to describe the concentration of a solution. It's just that molarity is actually probably the most common one that's used in introductory chemistry. And what you're going to do is you're going to take your moles of solute, so this is the stuff that's dissolving, okay, and you're going to divide it by the liters of solution. And I want to key in on this part right here because sometimes there's mistakes made where students want to put this volume in instead of this volume, okay? So there's going to be a difference between the solvent and the solution, okay? And for that reason, we tend to use these things. They're called volumetric flasks. And when you make a solution with a volumetric flask, what you're supposed to do is you're supposed to fill it up halfway with water or your solvent. You're going to pour in whatever you're trying to dissolve, and then you shake it up. You make sure it's completely dissolved, and then you're going to take it all the way up to the calibration mark. So on the skinny part of the neck right here, there's a gray line, and for this volumetric flask that's 100 milliliters, that calibration mark says, hey, that's when you've exactly hit 100 milliliters. Now, if for some reason a student messed up and they said, oh, I want to put 100 milliliters of solvent in here, you'd end up filling it all the way up to the calibration mark and then adding your solute, and you might end up above your calibration mark, and then you wouldn't have the right volume of solution. So that's why there's a process to all this. You have to fill it up halfway with water, dissolve your solute, make sure it's completely dissolved, and then when you hit the calibration mark the second time, like after you have everything dissolved, that's when you know you have exactly the milliliters or liters of solution, okay? So once again, when you're making a solution, halfway with water, pour your solute in, make sure it's completely dissolved, and then dilute it to the calibration mark, okay? So let's go ahead and do that, okay? And then we're going to actually do that problem on the board, but in that process, okay? So I'm going to draw kind of like a volumetric flask here. And we're going to say that this volumetric flask is bigger than the one that I have here. We're going to say that it's 250 milliliters. And what we're going to do is we're going to pour in 5 grams of table salt, which is sodium chloride. And what I want to figure out is, well, what's the concentration or what is the molarity of the solution if I do add 5 grams of sodium chloride, dissolve it in half the amount of water, and then take it up to the calibration mark at 250 milliliters, okay? Well, let's take care of our numerator first. We're going to convert these grams into moles. So 5 grams of sodium chloride. We're going to convert it to moles, so grams of sodium chloride to moles of sodium chloride. And then we're going to put the molar mass in here, which is 58.5, and I calculated that off the periodic table. If you don't know how to do this part, okay, I want to let you know that the video series here that we have, everything's placed in order. So if I ever do something that you don't know how to do, it's typically in a previous video. And converting grams to moles is in a previous video. So if you don't know how to do that, make sure you go back and check that out. But I'm going to take 5 grams and divide it by 58.5. And when I do that, I get to 3 sig figs, 0.0855 moles of sodium chloride. Well, I'm going to take that number and I'm going to put that in my numerator right here. So 0.0855 moles of sodium chloride. And I'm going to divide that by the liters of solution. Okay. Well, I have 250 milliliters of solution, so I'm going to take 250 milliliters. And most of you guys probably can do this in your head, but if you want to see the work, okay, I'm going to take 250 milliliters and convert the milliliters to liters, which is dividing by 1,000. So that comes out to 0.250 liters of solution. And when I divide 0.0855 divided by 0.250, I get an answer of 0.342. Now the units on this is going to be moles per liter. They don't cancel out. So the molarity is equal to 0.342 moles per liter, or what we call big M. We would call this a 0.342 molar solution of sodium chloride. Okay. Now I do want to take this one step further, okay, because when we dissolve sodium chloride into the solution, okay, or into the water to make the solution, it's going to ionize. So for every 1 sodium ion you have, you're going to have a chloride ion. There's actually no molecules of sodium chloride in here. They're nothing but, ions in solution. So we have something called the ionization process. So I'm going to erase this very quickly. We have something called the ionization process. And what that means is that the solid sodium chloride is going to dissolve in the water and it's going to make ions of the sodium chloride. So these are going to be aqueous. Well, if this is 0.342 molar solution and everything pushes to the right, okay, well, we have a 1-to-1-to-1 ratio. So as this turns into the ions, we no longer have this, but since this is a 1-to-1 ratio, it's going to have a concentration of 0.342. And since this is 1-to-1, it's going to have a 0.342 molar solution as well. Okay. If you want to see that a little bit differently, I'm going to take this 0.342, and instead of using big M, I can do moles per liter. And I'm going to put that in a train track. And that's moles per liter of sodium chloride. If you want to see this converted over, I could simply go from moles of sodium chloride to moles of like just the chloride ion, okay? And that's going to be a 1-to-1 ratio, 1-to-1, okay? So the moles of sodium chloride would be canceling out, and I'd have moles of chloride ions over liters, which is just molarity, and it'd be the same number because 0.342 times 1 divided by 1 would be the same number. So I don't care how you do it, whether through a train track or just recognizing the ratio, but you do need to come up with the molarity of the ions, and that's just as important as coming up with the molarity of, the compound sodium chloride. So a 0.342 molar solution of sodium chloride, really there's no sodium chloride in here. It's just sodium ions and chloride ions. So it really means chemically is that you have 0.342 molarity of sodium ions and 0.342 molarity of chloride ions. So I'd like to try this one more time, okay? I'm going to set up the problem, and I'd like you to pause the video and then try the problem on your own and then check your answer, okay? So we're going to set it up exactly the same way. We're going to use a 250 milliliter volumetric flask, okay? The only difference is going to be the chemical that we put in there, okay? So instead of putting in sodium chloride, let's go ahead and do 5 grams of calcium. We'll do calcium nitrate. And we all know that the formula for calcium nitrate is CaNO3. Okay, so what I'd like you to do, I'd like you to work this problem out, okay? Pause the video, and then when you come back, I'll be working on the problem. Okay, so hopefully you finished. First step is going to convert the grams into moles. Okay, so we're going to take our 5 grams of calcium nitrate, and we're going to convert the grams into moles. Okay, and the molar mass for calcium nitrate is 164 grams per mole because there's 1 calcium, 2 nitrogens, and 6 oxygens. And if you add all that up, it's going to equal 164 grams per mole. Okay, and that's going to give us the moles to 3 sig figs as 0.0305 moles of the calcium nitrate. Of course, we're going to do the same thing with the milliliters. 250. Let's try that again. 250 milliliters converted over to liters is going to be 0.250. Okay, and then when we calculate the molarity of the solution, okay, molarity of the compound in the solution, 0.0305 moles of calcium nitrate all over 0.250 liters of solution tells me that the molarity would be 0.122 molar solution of calcium nitrate. Okay. Now remember, when the calcium nitrate dissolves in the water, you're not going to find any molecules of calcium nitrate. They're going to go through the ionization process and split up into their positive and negative ions. And for every 1 positive 2 ion of calcium, you're going to have double the amount of nitrate ions. Okay? Why is that? Because of the ionization process. So if we do the ionization process over here, we would get calcium nitrate as a solid dissolving into calcium ions and 2 nitrate ions. So if this molarity is 0.122, okay, when it pushes over into the ions, all of this is gone, and because this is a 1-to-1 ratio, we get the same molarity of the calcium ions, but for every 1 calcium ion we get 2 nitrate ions, so the ratio is actually 1 to 2, so it's actually double this 0.122, which would be 0.244 for the molarity of the nitrate ions. So the nitrate ions are double the concentration of the calcium ions in the solution, 0.122 and 0.244 respectively. Okay? If this information has helped you not only calculate the molarity of a compound in a solution, but also figuring out the molarity of the ions in the solution, please give me a like, a subscribe, and even a comment. That really helps push the YouTube algorithm, this stuff out to other students that might be interested in learning the concentration or molarity of solutions.